All right, looking at problem number 3 to begin. For the triangle to be proven congruent by side, 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 name the additional parts that need to be congruent. Well, right now, they have marked this pair of sides as congruent, and they have marked this pair of sides congruent. So if we wanted to prove this to be congruent using side, 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 we still need these two sides congruent right here. So we would be looking at segment GE would need to be congruent to segment DL. Write a congruent statement for the two triangles. So now we're going to match up the corresponding congruent parts. If I call the first triangle, triangle GEO, triangle GEO, we have to match up the corresponding parts. So when I look at angle G up here, I notice that it is at the intersection of the segment that I just put 3 marks on and the segment that has 1 mark. What does that correspond to on the other triangle where the 3 marks and 1 mark intersect? D. So G and D are corresponding, so this would have to start with D. And then if I go from G to E, I'm moving to the other side of the segment with 3 marks on it. What would that correspond to on the other triangle? I'm starting with D. And then I want to move to the other end of the segment with 3 marks on it. L. So D, L, O. For the triangles to be proven congruent by side, angle, side, name the additional parts that need to be congruent. So I'm going to go ahead and erase all the marks that I made on this for the first 2 parts, A and B, and we're going to look at it fresh from the beginning. If I wanted to show these to be congruent by side, angle, side, well, again, I've got a pair of congruent sides here, and I have a pair of congruent sides here. By side, angle, side, I need the angle that is in between those 2 sides, or the angle where those 2 sides meet. What are those angle names?
Angle GOE and angle DOL.
Yes, angle GOE, this angle right here, and angle DOL, this angle right here. Angle GOE is congruent to angle DOL. Now I could use side, angle, side to show these 2 triangles are congruent. What else would you guys like to see from the review? Number 15? Absolutely. This is a really good one. All right, so the first thing that I notice in the image is that this angle right here is an exterior angle. It is outside the triangle. These other 2 angles, angle 2 and angle 1, are those also exterior angles? No, those are what type of angles? These are remote interior angles. They are remote because they are not touching angle 3, that exterior angle from the figure. And we have an exterior angle theorem that we learned right at the beginning of this module. The exterior angle theorem says that the measure of the exterior angle is equal to the sum of the 2 remote interior angles. All right, let's look at how big these angles are up here. It says that angle 1 is x minus 10 degrees. So I'm going to add that to my picture. X minus 10 degrees. Angle 2 is 3x minus 7 degrees. And my exterior angle, angle 3, is 2x plus 9 degrees. So my exterior angle, the measure of angle 3, is equal to the sum of my remote interior angles. So the measure of angle 1 plus the measure of angle 2. And now I'm going to substitute in what we have. Angle 3 is 2x plus 9. So we substitute that in. And then the measure of angle 1 is x minus 10 plus the measure of angle 2, which is 3x minus 7. Over on the right-hand side, we're going to combine our like terms together. I have x and 3x. That's going to combine to give me 4x. And then I have a minus 10 and a minus 7. That will combine to give me a minus 17. So on the right, I have 4x minus 17. On the left, I have 2x plus 9. Then we want to get our x's to the same side, so I'm going to subtract 2x from both sides. That would give me 9 equals 2x minus 17. Then I would add 17 to both sides. What is 9 plus 17? 26. So 26 equals 2x. And then we divide both sides by 2. What is 26 divided by 2? 13. So x is 13. And the other thing that they wanted me to do was to find the measure of angle 2. The measure of angle 2 is equal to 3x minus 7. So we're going to substitute in 13 in the place of x. What is 3 times 13? How much? 39. Sorry, I just didn't hear. 39 minus 7 would give me what? 32. So x is 13, and the measure of angle 2 is 32 degrees. Now, I do want to say that having graded this the last couple years, a question like this is one of the most often missed because we forget how to set it up. We forget that that exterior angle out there is equal to the sum of the two remote interior angles. And this was one of the most often missed questions on the first skills check as well. Because we've done a really good job of remembering that these two angles add to 180, and we've done a really good job of remembering that the three inside angles add to 180. But as a group, we seem to still be struggling with the fact that my exterior angle is equal to these two added together. Yes?
Did you go over question 10?
Question 10, absolutely. In triangle BRK, the measure of angle K is 7 less than 3 times the measure of angle B. The measure of angle R is 30 degrees. Find the measures of angles B and K, then classify the triangle by its sides and angles. So the first thing I'm going to do is I'm going to draw a picture to go with this. Something like this. And I know it's B R, and K. They told us up here the angle R is 30 degrees. So I'm going to come over to my picture and I'm going to add that. 30 degrees. K is 7 less than 3 times the measure of angle B. Do we know how big angle B is? No. So what could we call it? X. We're going to call angle B X. And then it says K is 7 less than 3 times that. So the measure of angle K, 7 less than means I have something minus 7. Just because you see the word 7 first does not mean it's 7 minus. 7 less than means I took 7 away from something else. 3 times the measure of angle B, so 3x. So the measure of angle K is 3x minus 7. The 3 angles in a triangle add up to how much? 180. So the measure of angle B plus the measure of angle R plus the measure of angle K equals 180 degrees. Angle B we are calling X. Angle R is 30 degrees. And then angle K is 3x minus 7. Equal to 180. Combining our like terms together, I have x and 3x, which combine to give me 4x. And then what do I get when I combine 30 with a minus 7? 23. So a positive 23 equals 180. I'm going to subtract 23 from both sides. What is 180 minus 23? 157. And then we divide both sides by 4. What is 157 divided by 4? 39.25. All right, so now we need to find the measures of angles B and K. How big is angle B? 39.25. The measurement of angle B is equal to X. So that would be 39.25 degrees. The measure of angle K is 3x minus 7 degrees. So I would have 3 times 39.25 minus 7. What do you get if you put that into your calculator? 3 times 39.25 minus 7. 110.75 degrees. All right, so we have 3 angles in this triangle. Remember, one of them was up here 30 degrees. Is this 30-degree angle acute, obtuse, or right? This is acute here. What about the 39.25 degree angle? Acute. And the 110.75 degree angle? obtuse. So if I'm going to classify this triangle by its angles, what type of triangle is it? Acute, right, or obtuse? Obtuse. And now we need to classify it based on its sides, yes. When we classify it based on its sides, it's either equilateral, isosceles, or scalene. This one is scalene. Why is this one scalene? Yes, all the sides are different, and we know that because all the angles are different. So obtuse, scalene. Right. Yes. Number 14, absolutely. Using the information below, draw and label a diagram. Triangle TOM is congruent to triangle DAN, and TO equals 4x minus 20, DA equals 2x plus 2, and AN equals 7x minus 12. So first thing we need is a diagram. So I'm going to draw two triangles. There's one. There's my second one. I want them to look as similar as possible because we were told that these triangles are congruent. So one of my triangles is TOM. The other triangle is DAN. And then we need to mark these up with their congruences. According to the congruence statement, angle T and angle D are congruent. So T and D get marked as congruent. What's another angle pair that's congruent? O and A. Angle O and angle A. And then finally, what else would have to be congruent? M and N. Remember, the triangle congruent statement doesn't just tell me about angles that are congruent. It also tells me about sides. When I look at the first two letters here, that would be side TO. That corresponds to what on the other triangle? DA, first two letters. So TO and DA are congruent to each other. What's another pair of corresponding sides that would be congruent? OM and AN, middle and last, middle and last. OM, AN. And finally, that means what other two sides would have to be congruent? MT and ND. So that is the first thing that they asked me to do. It said, using the information below, draw and label a diagram. Now I can take the rest of the information that they gave me and add it to my picture. We have that TO is 4x minus 20. So this side right here is 4x minus 20. DA is 2x plus 2. And AN is 7x minus 12. So like this. We want to solve for x and find the length of OM. Which two sides can I set equal to each other? If I want to find x, which two sides do we set equal? TO and DA. They both have one congruence mark on it, and they each have their own expression that I can take and set equal. So segment TO is congruent to segment DA. That means the measurement of segment TO is equal to the measurement of segment DA. TO is 4x minus 20. We're going to set that equal to dA, which is 2x plus 2. And now we're going to solve this for x. So I'm going to get my x's to the same side. I'm going to minus 2x from both sides. So I get 2x minus 20 equals 2. Then I add 20 to both sides. So 2x equals 22, which means x is how big? X is 11. 22 divided by 2 gives me 11. And then it says we're also supposed to find the length of segment OM. Well, that's this right here. It doesn't have an expression on it. How can I do that? With the other one, it's equal to what? AN, which does have an expression. So we can say that OM is congruent to AN. So the length of OM is equal to the length of AN. So OM equals 7x minus 12. OM equals 7 times, we just found out that x was 11, so 7 times 11 minus 12, so 77 minus 12, we get 65. All right, what else would you guys like to see? Number 20, absolutely. Number 20 is the proof on the very back page. It is a flowchart style proof. Well, the first thing I see I can fill in, there's 2 boxes that say given. And so I'm going to take my given information and put it above that. I'm going to take this piece of given information and put it in the first box. Segment IM is congruent to segment KN. And I'm going to take this piece of given information and I'm going to put it over here. Segment IM. Oh, sorry, I wrote the wrong thing in the first box. That shouldn't say congruent. I said I was going to put the parallel in the first box. My apologies. We're putting congruent in the second box because that was the second piece of given information. Typically, it wouldn't matter which one I put where on my given information, but the reason I know it matters here is I can't get any more information from IM and KN being congruent. I can get more information from IM and KN being parallel, and this tells me that I'm going to have 2 things that come from that piece of information. So I'm going to come over here to the picture. We're going to mark IM and KN congruent to each other and parallel to each other. Now when we see parallel, what do we draw? Draw a Z. When I come over here to these 2 line segments and I go to draw my Z, IM and KN, I've got 2 different segments that I could trace over to make a Z-type shape. That's why there's 2 things that I can say here. That's why there's 2 boxes leading off of this one. If I connect these 2 right here, then I can find a pair of congruent angles. Up here, match orange to orange, and down here, match orange to orange. So angle MIL is congruent to angle KNL. or LNK. What type of angles are those that I find with a Z? Alternate interior. So this is the alternate interior angles theorem. Now I could have drawn my Z going the other direction. I could have drawn it like this, connecting it with MK instead of IN. That allows me to find another special angle pair that is congruent. Angle IML is congruent to angle NKL. Why would those two angles be congruent? Alternate interior angles theorem again. Anytime we draw the Z to find our angles, it is the alternate interior angles theorem. All right, so I've got two pairs of corresponding congruent angles, and I have one pair of corresponding congruent sides. These two triangles are congruent to each other, so I can say that triangle IML is congruent to triangle NKL. Why would I be allowed to say that based on the way these triangles are marked up? Look at, what'd you say, dear? Angle, side, angle. If you look at just one of the two triangles, we have an angle marked here, we have a side marked here, and we have another angle marked here. So angle, side, angle. Says we're supposed to go one more. What are we being asked to prove in this proof? That segment IL is congruent to segment LN. What would we call those parts? Yes, those are congruent, but they are also corresponding parts. So why can I say that these two segments are congruent to each other? Yep. CP, corresponding parts, CT of congruent triangles, C, are congruent. Corresponding parts of congruent triangles are congruent. CP, CT, C. What else would you guys like to see? We've got a little bit more than 10 minutes left. That's enough time for 2 or 3 problems depending on the length. Number 18? Absolutely. Which one does not prove the triangles congruent? So let's look at these one at a time. Let's mark this one up. Angle MAH, that's this angle right up here, is congruent to angle TAH right here. Angle AHM, that's this angle right down here, is congruent to angle AHT. That's the corresponding angle on the other side. And what in this picture would I be allowed to mark as congruent even though it wasn't part of the given information? AH is congruent to itself. What do we have marked up inside the triangle? Angle, side, angle. Am I allowed to use angle, side, angle to prove triangle congruence? Yes. So angle, side, angle. That works. So we need to move on to the next one now. So I'm going to erase all my markings except for that shared side there. It says angle M is congruent to angle T. And angle AHM, well, we said that AHM was this angle right here, is congruent to angle AHT. That would be the corresponding angle on the other side. What do we have marked up now? Angle, angle, side. Or side angle, angle. Are we allowed to use that? Yes. So that wasn't it. Part C, segment MH. Here's segment MH. It's congruent to segment TH right here. And angle T is congruent to angle M. What does that give us all marked up here? Yeah, that's angle side side or side side angle. Are we allowed to use side side angle? No. So this one is not going to prove the triangle's congruent. Let's look at why D does. D says angle AHM is 90 degrees. So right here. And angle AHT is 90 degrees. And then AM is congruent to AT. That also looks like angle side side. Why is this one not angle side side? Because of this right angle right here. Whenever we see angle side side, but it's a right angle, that means this is a situation where we have hypotenuse, leg. So this one would be HL, which does work. What else would you guys like to see? You want to see 19? Did you have one in mind? Number 7? All right, let's do 19 and then 7 because 19 is fast. If K is the midpoint of JL, let me sketch this out. K is the midpoint of JL, then JK and KL are congruent, or the measurement of JK equals the measurement of KL is true because, what did we say K was again? Midpoint. So why could I say that these two smaller segments are congruent to each other? Midpoint theorem. Technically speaking, because it's equal and not congruent, to be very technical, that's definition of midpoint. But if you wrote midpoint theorem, I would not count that as wrong. But midpoint theorem is when we say that they are congruent. Definition of midpoint is when we say that they are equal. Angelina, you said number 7? All right, let's go look at number 7 now. Fill in the blanks to make the sentences true. An acute triangle has how many acute angles? 3 acute angles. How many obtuse angles does an acute triangle have? None. How about right angles? 0. That is for my acute triangle. An obtuse triangle has how many acute angles? 2 acute angles. How many obtuse angles? 1. And how many right angles? 0. And then a right triangle has how many acute angles? 2. How many obtuse angles? 0. And how many right angles? 1. Yes. There's a right triangle is going to look like this. Here's our right angle. These two angles will both be acute, less than 90. We see something similar happen when we look at an obtuse triangle, like this. We have our obtuse angle. And these two angles right here would both be acute, less than 90. All right. On Canvas, the answer key is posted. If you look on our Canvas page for today, it says review for Module 5 test day 2. The videos will be here as soon as all of the classes are completed for the day, so you can watch the videos from the other class periods as well. And the Module 5 test review answer key is located at the very, very bottom of the page, and it does show all of my work for these problems.